Today's topic is river problem. This is another big area where the students are confused, particularly to find what is the relative velocity VBR and what is the absolute velocity VB of the boat. So I am going to explain this today. I am DATTA sir. I am an IIT JEE faculty for last 30 years. And I have seen many students, they are struggling with this type of problem. About to find which one is relative velocity, which one is absolute velocity. So I am making this video for your benefit. If you are benefited, like this video and share this video as much as you can. And since I will be making this video and posting it regularly, subscribe to this channel and press the bell icon so that you can get notification of that. Also, in the comment box, you give your comment what more concept you want, then I will make video of that type of concepts. See, in a river boat problem, when a boat is going, say, from A and it wants to cross the river. Suppose it wants to go to C, just opposite to this point. And if it actually moves towards B, then there is a river velocity towards BC. River will push it and send it to the point C, so that although he started with velocity towards AB, he ended up with velocity AC. In a similar way, if suppose he starts perpendicular to the river velocity and wants to reach the point just opposite to that starting point, he is pushed by the river so that he goes in a slanting way. So in both the cases there are three velocities. One is VR, that is velocity of river, one is VBR, one is velocity of boat with respect to river, and another is VB, which is velocity of the boat, means absolute velocity of the boat. Now, which one is what? VR means velocity of river, you have no confusion, it is along BC. But out of AB and AC, which is absolute velocity VB and which is relative velocity VBR, you have lot of doubt. I am giving you a very easy solution. You do one thing. You imagine some observer, you place him on the bank of the river. Place him on the bank of the river. And we see in his eyes, suppose he is stationed at A in the upper diagram. In that case, if he is rest, means he is in ground frame, the observer is in ground frame, then whatever he will see actually, that will be the velocity from ground frame. So actually what he sees that river goes from A to C. That means the velocity along A to C is the ground frame velocity, means absolute velocity. Whereas the velocity from A to B is the relative velocity of the boat with respect to river. Now, if we can do also this, if we want to find the velocity with respect to river, let that observer at A move in the direction of river velocity with the same velocity as river. So in that case, by these slanting lines, you see, as the person proceeds with the river, he sees the boat behind him, so that all the slanting arrows give the respective position of the boat on different positions. So ultimately he sees a velocity parallel to AB, means the velocity AB is the velocity seen by a person moving with the river. That means AB is the velocity of this boat with respect to river. Now come to the equation of relative velocity. We know VBR equal to VB minus VR. So VB becomes VBR plus VR. That means VB is the resultant of VBR and VR. Now in this triangle ABC, you apply the triangle law. You see what is VB here. VB is AC. VB is AC. Now from the triangle law of addition of vectors, you can find that vector AB plus vector BC equal to vector AC. So it tallies with the equation VB equal to VBR plus VR. That means whatever I have told is supported by triangle law of addition of vectors. So you can very easily find out this. Again, when suppose the man wants to cross the river perpendicularly, but he is pushed in a slanting direction, then also the man on the shore, means observer, he sees the boat actually go in the slanting line. So that slanting line will be the actual velocity, means VB, and the perpendicular line in which direction it started, it will become the velocity of boat with respect to river. Here also, if the person moves with the river in the direction of the river speed, then every moment he will see the boat just perpendicularly above him, so that every time he will see the river velocity of the boat in a perpendicular direction. So that means that is the velocity as seen from an observer moving with the river, or that perpendicular velocity is the velocity of the boat with respect to the river. So I think this is clear to you. Now we will come to another important thing, that is called drift. What is a drift? Means a river, in a river velocity is say VR. You see the green diagram. A boat wants to go from A to B, but ultimately reaches to C. So that BC is the distance by which the river pushes the boat. It is called drift. Now the velocity of the boat with respect to river, let us say we take it as V. V will have two components. One is V cos theta perpendicular to the river velocity. One is V sin theta in the direction of river velocity and opposite to river velocity. Now the perpendicular component V cos theta will help the boat to cross the river. So that time to cross will be d by V cos theta. D is the width of the river. Now t equal to d by V cos theta. This is the time to cross. Now this t is minimum when the denominator is maximum, means cos theta is 1, means theta is 0 degree. That means it will take minimum time when it starts perpendicular to river flow. But mind it, if it starts perpendicular to river flow, it will ultimately reach at a point further to that point, means it will be drifted. That means if he starts perpendicular to the river flow, his t will be minimum, means time will be minimum to cross, but his distance travelled will not be minimum. Distance travelled will be more than the width of the river. That is to be remembered. Again, the drift is BC, we know. What is BC? See, the boat is being pushed by the river in the right direction and the V sin theta is in the left direction. So net velocity is Vr minus V sin theta. That particular velocity is helping for the drift. That particular velocity into time t gives the drift. Means BC equal to Vr minus V sin theta into t. That is Vr minus V sin theta into dy V cos theta. If the drift has to be 0, that means Vr minus V sin theta has to be 0 because t cannot be 0. That means Vr has to be equal to V sin theta or sin theta equal to Vr by V. So these are a few important points about the river problems, river boat problems. These problems are not difficult, but it is confusing. And very often students find it difficult because they cannot decide which is Vr, which is V. So you just note down whatever advice I have given. It will be very easy to you. I hope you have understood the concept. I will come to you with different concept again in my next video. Till then, wait for me.